That's 3 over 1. Multiply across, you get 2x plus 18 over 23 equals 6. Yeah, this is where things are going to get bad.
Minus 18 over 23.
Subtract the 18 over 23 on both sides. So I have the 6 here. I'm taking away the 18 over 23. Yeah, and see, there's no way I can avoid it. I've got to put these together, which means I'm going to have to do the cross thing. But I still think this is better. I don't know. You have your own opinion. I'm not here to sell you on any method over the other. You get to choose which one you want. So looking at it, 6 over 1?
Yeah.
Okay, and now I'm going to come over there and do that little cross thing. So I have, don't forget, you still have 2x, don't you?
Yeah.
Okay, and now I do 23 times 6,
138.
138.
Mm-hmm.
And then 138, take away what? 1 times 18, so take away 18, and then over, straight across the bottom, 23. So 120 over 23?
Yeah. Now you have to divide 2.
Yeah, so now you divide 2. Divide by 2. Or, instead of dividing by 2, you could multiply both sides by what? The reciprocal of 2, which would be 1/2. And again, that's something you would choose what you want to do there. What do y'all want me to do? Divide by 2 or multiply by 1/2? Divide by 2? Divide by 2?
Yeah, divide.
Okay, divide by 2. So if I divide by 2, look at what happens. Divide 2 here, it goes away, I get x. Divide 2 here, and this is where you've got to do your keep dot flip. So keeping the 120 over 23, keep that. Keep dot, what am I flipping over?
1/2.
I'm flipping over 2 over 1. So I'm flipping 2 over 1, it's becoming 1/2. And to do that, you multiply straight across, you get 120 over 46. That does reduce. 60 over 23. Is that what we had?
Yeah.
Yep, that should be what we had the other way. I don't know. I mean, I think on one like this, you could argue that both ways sucked. But what do y'all think?
Got to the crappier part faster this way.
Yeah, there you go. You hit the shit hit the fan faster this way, but you didn't have as much of it, right?
I feel like it's much easier because you don't have to deal with as much fractions.
Yeah.
I know you still have to deal with fractions here, but not as much as the other.
Yeah. Let's give me your other homework problem. What other homework problem did I give you? Can I erase?
Yes.
Yeah.
It's 3x minus 5y.
3x minus 5y. What?
I didn't get what it was.
What is it?
Oh, hold on. I didn't get what it was equal to.
Okay.
I have the next one. It's 4x.
You want to give me the, okay, 4x.
Equals negative 12.
Well, okay, hold on. 3x minus 5y
Equals negative 12.
equals negative 12
And then 4x plus y equals
plus y equals
7.
7.
It's because on the first one I didn't have negative 12.
All right, that was one of your homework problems, and hopefully you did that with substitution. But now we're going to try elimination. Looking very quickly, my x's, my y's, my numbers are all lined up, right? Everything's lined up. If I add straight down right now, do the x's go away? No. Do the y's go away? No. Okay, so I'm going to have to do something. Now, would you rather work with the x's or the y's? The y's. Why? Why the y's?
Because you have y by itself.
All you need to do is make this right here a what? 5y, and you're done. Because then they'll cancel, right? That's better than doing the x's, because if I did the x's, these aren't going to cancel unless I make this a what? Think about it. Multiply these two numbers together, what do you get? 12? I need to make this a 12x and this a negative 12x. So I need to multiply both of them by something, right? Whereas if I work with the y's, I only have to make the bottom one. Is this all becoming a little more clear, what I'm trying to accomplish?
Yeah, so you don't have to always do something to both.
You don't. You could do something to just one or both. It's really depends on what the problem is, and it also depends on what variable that you're attacking. Like we're going after the y's here, right? Because it seems easier. So I'm only going to need a 5 to pass through here. Just make sure that these have to be opposites, right? Mm-hmm. Opposites. I do want to write this down. Hold on. If you were like really adamant about going after the x's instead of the y's, like you're like just absolutely wanted to do it that way, then what I would need here is a 4. If I do that, that's going to become 12x, right? I would need -3 here to make that a negative 12x, and then they would cancel. If you do it this way, it will also give you the same answers. It's just here you're going to get the y first, because the x's will cancel. You get the y first, then go back and get the x. Here we're going to get the x first, then go back and get the y. But I think the one in red's easier, don't you? All right, so let's do that. Hey, I heard something. The college president sent out an email to faculty the other day. You may already know this. Are any of y'all nursing majors? Nursing? Do y'all know that they're bringing that SAC has a nursing program, San Antonio College? They're going to bring it here. We're going to have a nursing program here. Now, it may not happen soon enough to impact you, but it's going to happen they said soon. So you can get your nursing.
I was a nursing major.
Yeah, so anyway, that's kind of exciting news for people who are in nursing. But
Chemistry and anatomy.
and starting next semester, they're bringing the EMT. You know EMT?
Oh, yeah.
Emergency medical, like, you know, on driving in the ambulance.
Yeah, for like the fire department.
Yeah, that you can become an EMT and go through the program here, and then also paramedic and EMT training or whatever. You can become certified here. So anyway, pretty cool. All right, here we go.
Yes, I got a picture and it exploded when I was at the light.
All right, so the top equation stays the same, right? And the bottom one becomes, whoa, wait, hold on. What the hell? Oh, yeah. Distribute, right? 20x plus 5y, right? Plus 5y equals 35. And now add down. Now add down. So 23x, those go away, and you get 23 here as well, right?
Yeah, 23.
And then if you divide both sides by 23, you get x is 1. Y'all are funny. In my class this morning at 9 o'clock, I couldn't get them to talk. They were all being so, and then someone said, did you see that accident? And then they were just, I think y'all were talking about the same accident. Yeah. The car, some car or something?
It didn't crash.
It didn't crash, just caught on fire or something?
Yeah. It just like overheated and cut.
Oh, okay. You have a picture. Yeah, but same thing. They were just like talking about the whole thing. Oh, that's cool. Yeah. Sorry, not cool. Sorry.
The guy
Right here,
like he was just standing there, like staring at the floor, and I was like,
What kind of car was it? Could you tell?
I don't know what it was, but it wasn't like a nice
This
car.
is when it actually
old.
exploded.
Okay.
Like,
Okay.
right after it had
So
exploded.
probably just had issues, you know, or just to catch on fire like that.
Maybe he lit it on fire.
No.
Maybe he wanted an
looked
insurance
really
claim.
sad.
Okay. All right. Getting back to this. What do we do now? We're losing track here. What do we do now?
Plug it in.
Plug that x into where?
You can do 4x
equation.
Any of them, right? Which one do y'all like?
4x plus y.
I like 4x plus y equals 7. I like this one. This one just looks nice, right? That has too many numbers. So 4x plus, not 7. 4x plus y equals 7. And so replacing the x with 1, you get that, and then that's a 4. 4 plus y equals 7. Just subtract 4 and you get 3. That should match your answer you got if you did the homework problem. I would say that when your answer, when you can kill off a variable with just one number, I think this method by far beats substitution. When you have to do two numbers, it can be a little bit weird. And when you have a lot of fractions, it can be weird. But like I said, this is the method I prefer. On a test, I'm going to give you a system of equations, and I'm going to just tell you to solve it. I don't care how you do it. Well, you need to do one of the two methods, but I don't care which one. All right, how are we doing? So I have two things. Let me first cover what I will test you on, then I have something else that I may share with you if we have enough time. All right, we're going to do a word problem. And I don't want you to freak out, okay, because it's a word problem, right? But we're going to use what we just did to solve something meaningful, right? So before I give you the actual problem, I want to talk to you about mixtures. So if I told you that I had this jug, right? And let's say that this jug held 10 gallons. So I have this 10-gallon jug, right? Boom, there it is. And what I'm going to do is I'm going to put water in it, and I'm also going to put salt. So I'm going to make what's called a saline mixture, saline solution, right? Water, salt, stirred up. So we've got this saline solution. And the way it's going to work is that I'm going to put 2 gallons of salt. I know that's a lot of salt, okay? 2 gallons of salt, and then it'll be 8 gallons of water. Two gallons of salt poured in, 8 gallons of water stirred up. I should have 10 gallons of a mixture, yeah? If we were to do something like this, then we would say that this is a 20% saline mixture. 20%. Now, where am I getting 20% saline mixture from? Yes, but how am I getting 20%? I'm saying there's 2 out of what? The total? 2 out of the 10 gallons is salt. What's 2 divided by 10? 0.2. What's 0.2 is from a decimal to percentage? 20%. So a 20% saline mixture means that 20% of it is water and 80% of it is, 20% of it is salt and 80% of it is water. I said it backwards, sorry. Right? That's what 20% saline mixture means. Copy? Now, once you stir it up, it's all mixed together, right? If you could somehow separate them again, then you would have 2 pounds or 2 gallons of salt and 8 gallons of water. Okay, good? Yes?
Is it like with those chocolate bars, say 80% cacao?
Yeah. When you have chocolate bars, like dark chocolate has a lot of, is that what we're talking about? Yeah. Dark chocolate has a high percentage of cacao, whatever, and then the light chocolate has less, and then white chocolate has practically none. There's a place down off Broadway. There's a chocolatier place. You can go like sit and do a class, and they'll teach you about chocolate. You did it? That's where I learned about it too.
It's actually very educational.
It is. And then you get to like make some, right?
Yeah.
Yeah. Okay. All right. So, got it? Let me give you one more example. Let's say that we had a jug that contained, let's say that this jug was 7 gallons. And I told you that 2 gallons was salt. And that would leave how many gallons for water? 5 gallons water. What would be our concentration? What would be our percentage mixture here? So how would you do it? How would you figure out the percentage of salt? You go 2, and you divide it by how much we have total, 7. 2 out of 7 is about 20, about 0.28 roughly equals about 0.28, which is about 28% or so. Okay? So visually, right? Visually, here, if I could separate the water and the salt, I would have about 2 gallons of salt down there, right? And then the rest of it, the 8 gallons, would be water. In this picture, you know, there's only 7 gallons here, so 2 of it would be salt, and then the 5 of it would be water, yeah? 2 out of 7, 5 out of 7. There it's 2 out of 10, 8 out of 10. All right, assuming you understand that, now let's get to the question. So if you ever take a chemistry class, there are certain experiments that you do where you need like a saline mixture or an acid mixture or something like that to do some sort of reaction. And what will happen is they'll say, okay, for this experiment, we need a 13% saline mixture. And so then your chemistry professor goes into the back lab and they come back and they're like, here's the 13% saline mixture. Well, they didn't have a 13% saline mixture sitting in the back. What they had in the back was like a 50% saline mixture and a 5% saline mixture. So they've got something that has a lot of salt in it and something that has a little bit of salt. And they mix them together to create the 13%. The question is, how did they do that? Because if you have 50%, it's very strong. 5% is very weak. How much of each one do you pour in to stir up and get 13%? Do you understand the question? Mm-hmm. So let me phrase it all out here, all right? So let's say you have a 50% saline, that just means salt mixture. I'm just going to put mix. And a 5% saline mix. So you have that at your disposal. You got this big old jug of 50% saline, big old jug of 5% saline, right? Y'all don't seem as excited. Should I put flames in here? Let me put flames and wheels. There, I'll put wheels. There we go. Yeah, there's a car on fire. Y'all excited now? Yeah, all right, there we go. Okay. So we have this jug of 50%, this jug of 5%, right? So the question is this: how much of each must be mixed to have 6 gallons? Let's make a different number. Let's go 8 gallons of 13% saline mix. So I'm gonna, at the end of it, we need to have a jug that has exactly 8 gallons in it, and it needs to be exactly 13% saline mixture. Okay? That's the question. Somehow, some way, this is a system of equations, or else I wouldn't be asking, right? At some point, we're going to get to a system of equations. We're going to use either substitution or elimination. That's what we're going to do. All right. So I like to do these problems with a picture first, okay? With a picture first. So what I have is in the back room, I've got this jug, and all I can tell you about it is that it's a 50% mixture, right? And then I've got this other jug that I'm going to take these and add these together. When I say add, I'm just going to pour them together into some other container. This was 5%, yeah? And what I need is at the end to have a jug that has 13%, but I also need it to have exactly 8 gallons total. 8 gallons total in there, right? So I need to take some amount here, some of this, mix them together, and get 13%, 8 gallons exactly. So what we don't know, right, what we're trying to find is how much of each, right? So how many gallons of this should I put in? And how many gallons of this should I put in to get this? Well, we don't know how many, right? That's what we want to know. So I'm going to call X the number of gallons of the 50%. And I'm going to let Y be equal to the number of gallons of the 5%. I don't know, at this point, I do not know how many gallons of this and how many gallons of this I need to pour together to get this, right? I don't know. So I'm just calling those two amounts X and Y. Can anybody tell me one equation right now? X plus Y.
13.
Careful. What is X? The number of what? Gallons. And then Y is the number of gallons?
Equals 8.
Equals 8. What I know is that however many gallons of this I use, whatever it is, added to however many gallons of this I use, at the end has to end at what? 8. Right? So that's the very first equation I have. The first equation says that X plus Y must be 8. And this has to do with gallons, right? I'm going to put gallons here. That's the information I know. It's one equation. If I could just come up with one other equation, right? One other equation that would tell me something about X and Y being connected, then I would have two equations and I would have two unknowns, and then I could use a system of equations. Yes?
Would the other equation be 50 plus 5 equals 13?
Are you saying 50 or 50x?
50x?
It's going to be something like that. That's very close.
Wouldn't you convert it into a decimal?
Yeah.
You convert into a decimal. Okay.
So point
That it-
50x,
Yes?
just 50x.
0.5. We will do 0.5x
X.
So then
plus
0.05
0.05y must equal.
0.05
This is the. Oh,
y equals
okay, so hold on. Y'all are on the right track almost. Hold on. Let me slow it down. Okay? Everyone good with this one? Okay. I want us to go to this situation right here that we want to end with. Because this one I think is where it's most clear. This is a 13% saline mixture, right? It's a total of 8 gallons. My question to you is, how much salt is in here? How many gallons of salt is in here?
So you have to do the 13 over 8, right?
So how much salt? How much salt is here? Okay, let me put it this way. What if this was 50%? Could you tell me how much salt was here? If I told you this was 50%, then how many gallons of it would be salt? 4 gallons, right? What if I told you this was 25%? How much of it would be salt? 2 gallons, right? So the way to figure out how much salt you have is to take this number, written as a decimal, and multiply it times how many gallons you have. Someone do that on their calculator. 1.04? Okay, so look. If our end product needs to be 8 gallons and 13% of it has to be salt, then that means 1.04 gallons of it must be salt. So to figure out the big thing is to understand that to figure out the amount of salt you have here, you take the percentage times the amount. Percentage times the amount gives you the total you have. So how much salt do you have here? The percentage times the amount. What's the amount? Nope, that's over there, right here. How much salt do we have in this container?
0.5.
0.5 times, how much do we have?
8.
Nope, that's at the end. X, right? When we pour this in, how much salt are we pouring in? 50% of however much we pour in. So 0.5, this is 0.5x is how much salt we have here. How much salt do we have here? 0.05 times y. That's how much salt we have here. And when you add these together, it must come out to be the percentage times the amount here, which is this. So that's our last equation. 0.5x plus 0.05y must equal 1.04. And now you have a system of equations. The thing that most people mess up is this. They say, okay, 0.5x, 0.05y equals 0.13. They don't take into account the 8 gallons. They just say it has to be 13%. It's 13% of the total, so it's 1.04. Do I need to run through that again, or y'all feel comfortable with how I got that? All right, can we solve this? Oh, wait, I'm off camera over here. Sorry. Let me put that. That's off camera. So let me put the Let me put the system over here. Okay, so we start first with the amount. We have X gallons of the 50% plus Y gallons of the 5%, must be a total of 8 gallons. Then we have 50% of the X mixture plus 5% of the Y mixture must equal 13% of the 8-gallon mixture, which was 1.04. Let's do elimination. This might be a little tricky. How can we get these to cancel? We're going to have to use decimals. Sorry. We're going to have to use decimals. You need this to be what up here? Negative 0.5. Everyone agree? Negative 0.5 would make that go away? So I'm going to multiply by negative 0.5. Get your calculators out because you might need them here. Distribute that, maybe not, but go here, here, and here. And then that will give us our new system. So we get this new system, bless you, negative 0.5x, negative 0.5y, and then should just be negative 4. Because negative 0.5 is really negative 1/2. So half of 8 is 4, but then negative. And then the bottom equation we're not touching, right? 0.5x plus 0.05y equals 1.04. And now when we add down, right, when we add down those x's should go away, shouldn't they? Add these down. Anyone have a question? Anyone? We're all good? X's are gone? Okay, be careful. Do this on your calculator if you need to. You're doing negative 0.5 and you're adding 0.05. Negative 0.45y. Negative 0.45y equals, same thing here. Be careful with things here. This, I believe, is negative 2.96. Someone double check me here.
Yeah, you got it.
Got it? Negative 2.96.
You're really good at doing math.
Oh, thanks. I don't feel like I'm good at it. Everyone thinks that math people are like human calculators. That's not the case. All right, so I'm divide now. So I get y is equal to, what do you get? Anyone? You're doing negative 2.96 and dividing by negative 0.45. 6.5777. Let's just go 6.58. Let's just round it. 6.58 is y. And now we go get x. And which equation looks the best to you to get x? The very top left one, right? X plus y is 8. Replace x with 6.58 plus y equals 8.
You're replacing y.
Yeah, I did the wrong one, didn't I? Thank you. Plus 6.58 equals 8. 1.42. Double check me. What is it? 1.3. Wait, hold on. See, you shouldn't have said 3.2?
2-1.
No, not divided. Subtract.
It's 1.42. You got it right.
4.2?
Yeah.
Yeah, okay. Yeah. 1.42. Subtracting 6.58 on both sides. So we replace the y right here with this and then subtract it on both sides and we get this answer. Now, let's think about the answer and see if it makes any sense. We have 50% mixture, right? We have a 5% mixture, and we wanted to end with 13%. So just logically speaking, our answer, 13%, is closer to 5% than it is 50%, right? So we shouldn't need a lot of this, right? Like we do too much of this, it's going to be super strong. So we should need more of this than we need of this. Well, how much are we saying we need of this? 1.42 gallons. How much of this? 6.58. We put those together, we'll have exactly 8 gallons, and the mixture will be exactly 13%. Well, we round it a little bit here, but close enough. So that's the way it's done in like chemistry lab. If you have like an acid solution or saline solution, in the back they have certain percentages already pre-mixed. And then they create what they need for the experiment by doing this. Now, I promise you that they just go to an app on their phone and it just spits out how much they need of each one. But this is the actual mathematics behind it. Okay? So what I would like for you to do for homework is I'm going to give you a couple more systems so you can try elimination. I'm going to give you, you want 1 or 2 of these to practice?
1, 2.
I'll give you 2. I'll give you 2. So for homework, let's do a couple of systems. I'll give you kind of one that's uglier. Okay, those are I'm giving you those 2 systems. Those 2 are going to work out nice, all right? Gosh, this purple, I can't. Purple really likes to stay on the board. Okay, those are your 2 systems. And then for 3, let's say you have a 65% mix, and then you have a 10% mix. And what I want is, so this is what you're given, right? You're given this. You have that sitting in the back storeroom. And it could be salt mixture, it could be acid. That really isn't relevant in the problem, right? Here's what you want to end with. I want you to get 25 liters. Now, liters and gallons has no relevance other than your answer is going to be liters instead of gallons. I want 25 liters of, let's go with 32% mix. And then let's go with an 80% mixture and a 3% mixture, and I want 12 gallons of 8%.